Hello, I am Hinavani. So our next chapter is exponents. In these exponents, we learn about the laws of exponents and positive rational number as a exponent, negative rational number as a exponent. What is mean by exponent? We saw the sum like a raised to 1, or 2 raised to 3, 4 raised to 2, 6 raised to 1. These all raised to 1, raised to 2, raised to 3, all these are called as exponents. The degree और जो सर पे चढ़ के बैठा है उसके, that is known as exponent. So for any natural number p, the exponent is defined as p raised to n. How we give that exponent? So if suppose I have number 2, okay, 2 is a natural number. Number 2 is a natural number. If I multiply 2, 2, 2, 2, how many times I had multiplied? 5 times. So I just, instead of writing such a lengthy 2 into 2 into 2 into 2 into 2, I will just write 2 raised to 5. So these 5 shows how many times 2 is multiplied with the 2. So if the degree or the exponent is 5 and the natural number is given, so you just have to multiply that natural number that much times. Means, for example, if 10 raised to 2 is a number, so it means 10 is multiplied 2 times, means 10 into 10. So answer for this 10 raised to 2 is 100. Okay, if I say 7 raised to 4, so 7 is multiplied with the 7 4 times. So just multiply 7 7s are 49, 49 7s, and whatever answer you got, that 7s is your answer. So n shows the number of times that natural number is multiplied with itself, and that shows its power. So if infinite times we multiplied p with p, then p raised to n is the symbol to denote it. Okay, now see, if a number, natural number, or we say integer is there, that is negative number is there, -2 is there. So if the exponent of -2 is positive, then but even number or odd number, that changes its plus or minus sign. Okay, because if you multiply -2 5 times, you get negative answer, because -2 multiplied by -2 becomes +4, -2 multiplied by -2 becomes +4, 4 4s are 16, but 16 is multiplied to -2, so answer is -32. So if the negative number is there and negative natural number is there, and if its exponent or its power is even, then answer is positive. If its power or exponent is odd number, then the answer is negative. Okay, now for all rational numbers a, in case of the negative exponent, it is expressed as a raised to -n, and this a raised to -n can be written as 1 upon a raised to n. Now I told you about the negative rational number, but if exponent is negative, this can be written as 1 upon a raised to n, means it becomes positive in the denominator if it is negative at the numerator. So we just write its reciprocal to make it positive. Okay, so for example, if 2 raised to -3 is there, you can write it as 1 upon 2 raised to 3. Okay, this you have to understood. Now some laws are there. If base is common, a raised to m multiplied by a raised to n. So here a is known as base of the number. So if base is common, a is common, then we just add the power, means a raised is equal to a raised to m plus n. If they are in division, we subtract their power, m minus n. If our equation is in the form a raised to m raised to n, then we multiply m and n, and we can change their position. We can write a raised to n raised to m also. If two number are in multiplication and their exponent is common, so we can write it as a raised to n multiplied by b raised to n. Same for the division also. Okay, common exponent power we can take out from both the number. Okay, now if they are in division and they have different exponent, we can subtract them. If they are in multiplication, we can um, add them. Okay, but if x raised to a divided by x raised to b, now according to law, x raised to a minus b, we write for this x raised to a minus b, answer is positive if a is greater than b, but if a is less than b, then you got negative exponent. So if we get negative exponent, then we can write 1 upon x raised to b minus a, because b is greater than a. Ultimately we have to take its reciprocal, so we'll already take its reciprocal. I thought you didn't get my point. I will show you. Suppose in one of the example, if it is like 2 raised to 3 divided by 2 raised to 2. So I can divide this as 2 raised to 3 minus 2. Okay, I subtract 2 from 3. But if the situation is like 2 raised to 2 divided by 2 raised to 3, now if I subtract 3 from 2, I will get negative exponent. So instead of subtracting 3 from 2, what I can do is 1 upon 2 raised to b. This is b and this is our a. So b minus a, that is 3 minus 2 will do. So our answer is 1 upon 2. If we don't do that, still we get the same answer. See, 2 raised to 2 minus 3, if we do, we get 2 raised to minus 1, and we already learned the law for it. If the exponent is negative, we can write its reciprocal. So we can write this as a 1 upon 2. Okay, so negative power become positive when it goes to the division side or divisor side. Okay, now the same, if the exponent is common and base are different, you just multiply the base and then common exponent can be written as a common. I will just show you when we solve the sum, then you understand it betterly. Now we'll move to the solved examples. Now see, here we have to find the values of two rational number or exponent numbers are given to us. First one is 4 raised to minus 3 upon 2. Now see, this exponent is negative, so we can write it as 1 upon 4 raised to 3 by 2. Okay, so this is what 1 upon 4 cube raised to 1 half. Okay, now simplify it. 1 upon 4 multiplied 3 times means what? 4 4 ja 16, 16 4 ja 64, 64 raised to 1 half. Now square root of 64. It means square root of 64 means what? We have to divide 64 such a that we can take its one part. So 8 into 8 is equal to 64. So 1 half of 64 is 8. So our answer is 1 by 8. Okay. Square and square root I already taught you in the first chapter. So 64 1 raised to half power, or if exponent is 1 by 2, then what it means, we have to take the square root of 64. So whose square is 64? So 8 ka square is 64. So its square root is 8. So 1 by 8 is the answer for the first question. And for the second, again you can solve. See, 512 raised to minus 2 by 9. So it is a negative number as an exponent. So we can write it as 1 upon 512 raised to 2 by 9. So same 512 square raised to 1 upon 9. If we simplify it, then it is 2. If we multiply 9 times, we get the answer 512. Okay, so we can write it as 2 raised to 9 raised to 2 raised to 1 by 9. Now see, we had already learned the law. If a raised to m raised to n raised to y, then what you do? A raised to m multiplied by n multiplied by y. So you just multiply these 3 powers of 2. So 2 raised to 9 multiplied by 2 multiplied by 1 by 9, 1 by 9, and this 9 will get cancelled. 2 raised 2 square means 1 upon 4. Okay, now we have to again there are some solved examples. We'll go through it for better understanding, and then we'll go to solve the practice exercise. Now see, evaluate this whole equation. So what is given? 27 raised to minus 2 by 3 into 81 raised to 5 by 4 and 1 by 3 divided by 1 by 3 raised to minus 3. Now see, whose cube root is, or whose cube is 27. So these all things you have to understand, because you should know the basic square and cube of 1 to 15 numbers. So see, if we multiply 3 times, 3 3s are 9, 9 3s are 27. So 27 is nothing but the 3's cube, and its minus 2 by 3 power we have to take. Now again 81 is the fourth, 1 by 4th of the 3. So 3, if we multiply 4 times, we got the answer 81. So 3's power 4 times is equal to 81. So again 5 by 4 is power of 8, and 1 by 3 upon minus 3. Now this whole equation will change. This 1 by 3 upon 3 will go to the numerator side, and this will come to the denominator side. But before that, we'll just simplify it in the better way. Okay. Now understood, this 3 and this 3 will get cancelled. This 4 and this 4 will get cancelled. This 4 along with the degree of 4. And now what remains is 3 raised to minus 2 multiplied by 3 raised to 5 divided by 1 by 3 raised to minus 3. Now when we write 1 by 3 raised to minus 3 is equal to 1 upon 1 by 3 raised to 3. So we can write 1 upon minus 3 is equal to, this also we can write as 1 upon 3 raised to 3. So this also will come into the multiplication with this. See, 3 cube we can write as 1 by 3 raised to minus 3. Now, what happens here? Minus 2 plus 5 become plus 3. So, when we solve this example further, we got 3 upon 3 divided by 3 upon 3. So, both the thing will get cancelled and our answer is answer 1. Again, I will explain you and then we'll stop here, or we'll take one example and then we'll stop. See, we have to evaluate this problem, but we should know whose cube is 27 and whose fourth root is 81. So, if we multiply 3 times, then we got 27. So, 3 raised to 3 is equal to 27. We just simplify 27 as a 3 raised to 3 and whose power is minus 2 upon 3. So 3 will get cancelled from numerator and denominator. Same here for 81. 3's fourth power is 81. So 4 will get cancelled. So our numerator be simplified as 3 raised to minus 2 multiplied by 3 raised to 5. It is like a raised to m multiplied by a raised to n. And we know the formula of a raised to m multiplied by a raised to n. If base is common, we just add their powers. So, we say a raised to m plus n. So, 3 raised to minus 2 plus 5. So, the numerator becomes 3 raised to 3. Up to this, I think you understood. Now, what happens to denominator? See, 1 upon 1 by 3 raised to minus 3 is equal to 1 upon 1 by 3 raised to 3. Now, this means 1 raised to 3 and 3 raised to 3. Okay. Now, this already here some numerator is there and this whole numerator, this rational number is in division, so we do its reciprocal easily. So this is nothing but 1 numerator upon 3 cube, because see, it is like numerator is there, big numerator, and this is 1 upon numerator divided by denominator, so it becomes denominator upon numerator. Second one, this numerator is n1, which is 1 here, so it becomes 3 by 1. 3 by 1, 1 has no value, 1. So 3 cube. So the denominator after simplifying, it becomes 3 cube. And our final numerator simplification is also 3 upon 3. So 3 upon 3 and 3 upon 3 from both the side will get not cancel, but 3 upon 3 ones are 3 upon 3. So our answer is 1. One more example we'll take, then you can understood how we can do it. Now see, 625 raised to minus 1 upon 2 raised to minus 1 upon 4 raised to 2. Now 625, whose square is 625? So 25 ka square is 625. So it is 25 raised to minus 2 raised to minus 1 half raised to minus 1 by 4 raised to minus 2. Now, if power ka power is there, we just keep the base common and we multiply all the powers. We multiply all the powers. So 2 multiplied by 1 half minus multiplied by minus 1 by 4 multiplied by 2. So 2, this and this 2 get cancelled. 2 and this become 2 2s are 4. So our final answer is 25 raised to 1 half, and whose square root is 25? Whose square is 25? So square root of 25 is 5. So our answer here is 5. You just see 625 raised to all the things. You just simplify this and we get our answer as a 5. Okay, now the next question is you have to evaluate this equation. Now 1 by x whose power is minus 12, whose power is 1 by 4 and whose power is minus 2 upon 3. Now what we do, we keep the base again common base at the base side and we multiply all the powers. We don't have a need to take its reciprocal because minus minus become plus already. So 4 1s are 4, 4 3s are 12, 3 1s are 3. So this is 1 upon x ka square. So where is your answer? 1 square and x square. So B is our answer. So like this you have to evaluate 729 raised to minus 5 by 3 raised to minus 1 by 2. If we are going to solve this, 9 cube is 729. So 729 can be written as 9 raised to 3 multiplied by all these exponents. So this equation will look like 9 raised to 3 multiplied by minus 5 by 3 minus 1 by 2. Simplify it and we got the answer as 9 raised to 5 by 2. So 9 is nothing but 3 square. So 2 will get cancelled and 3 raised to 5 means multiply 3 5 times we get answer 243. Okay, now the next is this all equation is equal to 1 and we have to find the value of x. Now see, a raised to 0 is equal to 1. Okay, if this equation is equal to 1, so power of this a is equal to 0. So x minus 2 is equal to 0. So x is equal to 2. Okay, it is that much simple. Don't look at square root of a 6 and what we can do. Nothing else. We have to just think nothing. We just remind all the laws of exponents. A raised to 0 is equal to 1. If this equation is equal to 1, the exponent is 0. So x minus 2 is equal to 0. So x is equal to 2 here. Simple. Okay. Now the same way solved examples are there. You can go through it and in the next lecture we'll solve the problem based on this exponent. Again I will explain the laws of exponent once again and then we'll stop here. See, exponent is nothing but the power on the number, means it signifies that how many times that number is multiplied with itself. Okay, now if the exponent is negative number, we can write it as its reciprocal. Like for example, this one. If a raised to minus 1 means exponent is negative, then we can define it as, or we can write it as 1 upon a raised to n. Now some operations are we can carry on the exponents, like their addition, their subtraction. But when? If two rational numbers are in multiplication and their exponents are integers, m and n. Base is same, okay. If the base is same, then these exponents are added. if the numbers are in multiplication with each other. If base is same and if the numbers are in division, their exponents should be subtracted. If base is same and exponent is given, then just multiply both the exponents, keeping the base common. If in multiplication A is multiplied with B and if the exponent is n, that means it is the exponent of A also and multiplied with the B's exponent. Okay. And same for the division. Now, if x is a rational number which is greater than 0, means positive rational number, and a and b are the rational exponents. If a is greater than b, then if they are in division, subtract b from a. If x is a rational number, a and b are the rational exponents where b is greater than a. So if you subtract b from a, we get negative number. Okay, say c as a negative number. So again we have to do its reciprocal. So instead of doing all this manner, we can just solve it by taking its reciprocal already, x raised to b minus a. Okay, now if rational number is x which is greater than 0 and b and c are the rational exponents like x raised to a raised to b raised to c, we just keep the rational numbers at the base and we multiply all the exponents. Okay, if base is different, means one rational number and another rational number x and y, and if their exponents are common, then you can solve the problem by two ways. Find the evaluate for x raised to a, then multiply it with y raised to a, or you just simply multiply x and y together and then find its exponent. So these are some methods, or these are some equations, or these are some laws related to exponent, that if base is common and different exponents are there. For example, if 2 as a base is common and 2 raised to 3 multiplied by 2 raised to 4 is there, so what we do, keeping 2 common, we just add 3 and 4, so it is 2 raised to 7. If they are in division, 2 raised to 3 divided by 2 raised to 2, then what we do, we keep the 2 common and subtract 2 from the 3, so we do 3 minus 2 and solve it. Okay, if they are having different base, like 3 raised to 3 multiplied by 2 raised to 3, so it means we can solve this also, like 3 multiplied by 2 raised to 3 means 6 raised to 3, and evaluate it. Okay, these are some laws. So one law we understood while doing division. If see, the example is like 2 raised to 3 divided by 2 raised to 2, where 2 is a rational number and 3 and 2 are the rational numbers also. So here we can do 3 minus 2. But if the reverse situation is there, if 2 raised to 2 is divided by 2 raised to 3, where 3 is greater than 2, then what we do, 1 upon 2 raised to 3 minus 2 we can do. Okay. So these are some laws which we learn and we apply here, and based on these laws we have to solve the practice exercise. We had gone through some solved examples, and in the next lecture we'll solve the practice exercise. Till then, try to solve it. Bye.